All right, so this is Module 7, Homework 4, which is simplifying complex fractions. In this section, we're going to determine when I can immediately multiply by the reciprocal of the denominator or if I can simplify a complex fraction. So it's all talking about complex fractions. So before we even get to the nitty-gritty of it, we have to think, what is a complex fraction? A complex fraction is just a fraction and a fraction. So for example, 3/4 over 1/5. We have fraction on the top, fraction on the bottom, so it's just a whole mess of fractions.
Split it up.
Yeah, let's split it up. So if I have 3/4 over 1/5, I get easily confused. So that's why I go ahead and I bold that middle fraction bar. So fractions mean what operation? Add, subtract, multiply, or divide? Divide. So we really have 3/4 divided by 1/5. So really it's the same as we did in Module 7 Homework 2 or 1. Or one of those. Yeah, so we're going to keep the first one the same. We're going to change the operation from division to multiplication, and we are going to flip the second fraction. So that'll leave us with, you're welcome, 3/4 times 5 over 1. 3/4 times 5 over 1. So stay, change, flip. Stay, change, flip. So 3/4 times 5 over 1. So now we're multiplying. So how do we multiply fractions?
Straight across.
Straight across. So really, nothing new. Whoops. Multiplying straight across, 3 times 5 is 15. All over 4 times 1 is 4. Can 15 over 4 be simplified? Are there any factors that 15 and 4 have in common?
Negative.
Negative.
Boom goes the dynamite.
Boom goes the dynamite. We're done.
You're the worst.
You can't make fun of me? Too late, sorry.
You're a bad person.
I make fun of myself. It's okay.
Oh, last week.
Last week?
Wait, but it has -1 squared in common.
All right.
Okay, but that's
So-
excessive. I could take out 1,000,000 square
Yeah.
ones. One.
If we take out ones, it's not going to make it any simpler, so we're really not simplifying. Good point, though. All right, so let's keep going. Simplifying the complex fraction, 4 over 3x, all over 2 over 9x. So let's just write this as a division problem. So our middle fraction bar, we can write as 4 over 3x divided by 2 over 9x. So now it's a division problem. So now...
But that one's a simpler version of that one.
Yeah. So now we can just stay, change, flip like we always do. The first fraction stays the same. Our operation changes from division to multiplication. And we are going to flip the second fraction. So 4 over 3x times 9x over 2. So we can multiply straight across. 4 times 9x will give us 36x.
Over X.
All over 3x times 2,
6X.
6x,
That was opposite.
which it simplifies. So 36 divided by 6
6.
will give us 6. X divided by x,
1.
1. They cancel each other out. So our final answer, just 6. Boom. So stay, change, flip, and then multiply straight across. What questions, comments, concerns do you have for me so far?
Would we get a different answer if we stuff like 3x and try to match it to the 9x by finding the
To simplify right here?
simplify, like up.
Yeah.
If you move up and like try to make the LCDs the same, like the bottom fraction.
But we're not adding or subtracting, so we don't need an LCD.
So you need, okay.
Yeah, but if you want to simplify here and say, okay, 4 divided by 2 is 2, 9x divided by 3x is 3, you can do that too. 2 times 3 is 6. So where you can simplify wherever you want.
Okay.
Oh, I mean, either way, you're gonna do the same thing.
Okay.
So great question, even though I asked it for you. So good job.
You've got a pickle.
Yeah. All right, so next one, simplify the complex fraction. 2 over, sorry, I'm shaking it, it's making that table shake. 2 over x minus 4, all over x times x minus 4. Can I move this up a little bit? Same thing, we're going to take this middle fraction bar and we're going to write it using the division symbol. So 2 over x minus 4 divided by x over x minus 4. So it's now division, same thing over and over and over, stay, change, flip.
So now by the logic of the last question, we can go ahead after we flip it and cancel out the x minus 4s.
Bingo. You want to do that?
Yes.
Yes. Okay.
Yes. It makes me so excited.
Keep the first fraction the same. Change our operation from division to multiplication and flipping our second fraction. We are all flipping out. Okay. So yeah, so what do you notice? There's x minus 4 on top, x minus 4 on the bottom. So they cancel out. X minus 4 divided by x minus 4 goes to 1. So what's left over up top? 2 over x. Well, there you go.
Okay, how do we do that one?
You like these?
I like not getting all the extra stuff.
Oh, good.
Now
We'll
that
enjoy
is-
it while it lasts.
Well, that is a complex fraction in a fraction.
All right, so let's try a next one.
Oh, Lordy.
Let's try the next one. Next page.
That's not okay.
Sorry. Simplify the complex fraction. So same thing like we've been doing. I have 1 minus 2 over x divided by x plus 2 over 3x. So same thing. I had this fraction stuff up top and the fraction stuff on the bottom. So I'm going to take that middle division bar, that middle fraction bar, and write it as division. So that'll leave us with 1 minus 2 over x divided by x plus 2 over 3x. All right, order of operations. What do we do first? Parentheses. Parentheses. So that means inside our first set of parentheses, 1 minus 2x, I need to subtract that first. And then inside the second set of parentheses, x plus 2 over 3x, add that first. So 2 separate problems, do that first. Once we have that simplified, then we can worry about stay, change, flip. The reason being is this x plus 2 over 3x is multiple fractions. They're not together as one fraction, so when I flip it, I have to flip the whole thing. So I have to make it one big fraction to flip first.
Okay.
Does that make sense? Yeah, good answer.
This looks like a fraction on steroids.
All right, so just looking at our first fraction, our first set of parentheses, just dealing with this question first. 1 minus 2 over x. We are subtracting. Are these like terms?
No.
No, we need to make them like terms. What's our LCD? X. So that means I can rewrite 1 as 1 over 1, multiplying the top and the bottom by x. That'll leave us with x over x minus 2 over x. Now these are like terms, so I can combine them together as one big fraction all over x. So we have x minus 2 over x. So if you can do these problems, you can do all of Module 7 because it incorporates simplifying, multiplying, dividing, adding, and subtracting in one big problem. So I subtracted the first 2. Now doing the second 2. If we have x plus 2 over 3x, are these like terms?
No.
No, we need to make them like terms. What's our LCD? 3x. That means we're going to multiply the first fraction, top and bottom, by 3x. Second fraction is already 3x, so it's good to go. So 3x times x. is 3x squared. Good, thank you. All over 3x plus 2 over 3x. Now these are like terms, so I can write it all over 3x as one big fraction. So we're left with 3x squared plus 2 all over 3x. These are not like terms. I cannot add them. There's no GCF, nothing I can do. So we did everything we could inside the parentheses. We went as far as we could. I can't do anything else, so we're done with that.
Keep changing.
Right, so order of operations, say parentheses. We did that. Exponents, there's no exponents to deal with. And then multiply or divide. So now we're going to divide. Now we're going to say change flip. So our first fraction staying the same. It's going to stay x minus 2 all over x. Our operation's changing from division to multiplication. And we are flipping that second fraction. So 3x all over 3x squared plus 2. So now we are multiplying, so we can multiply straight across. So we have on top x minus 2 times 3 times x all over x times 3x squared plus 2. So what factors can cancel? X. But that's it. So up top we're left with 3 times x minus 2 all over 3x squared plus 2. And that's our final answer.
Did the 2 3s cancel out?
No, why? They're not like terms. Good, yeah. So we have 3 up top, and then on the bottom, this is one big factor. So 3x squared plus 2 is all one big thing. So because they're not the same thing, we can't cancel them out. Good question. Yeah, there's like imaginary parentheses grouping that together. Great question. Other questions?
Like if you were just to keep distributing, like didn't take out the x, eventually you would simplify back down to that.
If I were to distribute the 3?
Like if you just didn't see that the x and the x canceled out and you just kept going, like combined like terms and distribute. Like I don't know why you would do that. Like I was doing it without watching. Like I kept the 3 and the x together, and then distributed in.
Yeah, you don't have to want to distribute because we were only in factor form to see what factors, and that's more work that we don't need to do. So no, don't do extra work. Don't distribute it back in. Everything we're doing is factoring, so we're taking it out. Don't put it back in. But yeah, if you distributed, you'd be like, oh hey, let's see what factors can cancel. Let's take out a GCF so you get right back to where you're at.
Nice.
That's like grading. That's why it's not funny because I feel like you're obviously not getting it, but it's kind of funny because sometimes you like do that. It's like you distribute and then factor it out. Distribute, and it's like a never-ending loop, and you never know like when to get off the like never-ending loop. So then all of a sudden you just stop somewhere. So it's kind of funny. It's like, yeah, okay, we'll just stop right here.
It's just like there's nothing more I can do.
Yeah. All right, so let's try another one. Let's keep going. So simplifying the complex fraction, 9x squared minus y squared all over xy divided by 3 over y plus 1 over x. So I'm going to take that middle division bar and write it using the division symbol. So 9x squared minus y squared all over xy divided by 3 over y minus 1 over x.
Alright, the first one was pretty easy.
All right, so let's talk about the first one. Inside the parentheses, for one, it's all in one fraction, so that's good. So let's try to simplify this. 9x squared minus y squared. Can I factor anything there?
Yes. The x. No.
You can divide out x, y, could you not?
No, you can't.
Okay,
You can't.
so looking at the
You
top.
can't.
Never mind.
It's negative y. It's negative y. You can't.
You are just making sure. Okay, so let's think about 9x squared minus y squared. Let's try to factor this. What do you think about it?
They're perfect.
Difference of perfect squares. Thank you.
Squared.
Ah. So 9x squared is 3x and 3x. One's positive, one's negative. Y squared is y times y. All over x times y. Can't do nothing there. We have it factored, nothing canceled, but at least it's ready for us to cancel. So that's all we can do with that first fraction. So, divided by 3 over y minus 1 over x. Are these like terms?
No.
No, what's our LCD?
X, Y.
Good, xy. Our y has to be there, by the way. X has to be there, putting them together, xy. First fraction has a y, but it needs an x. So we're going to multiply the top and the bottom by x. Second fraction has an x, needs a y. We're going to multiply the top and the bottom by y. That'll leave us with 3x over xy minus y over xy. Now they are like terms. Now they are both over xy. So you can rewrite it as one big fraction all over xy. So 3x minus y all over xy. So now bringing our two stuff together. We have 3x plus y times 3x minus y all over xy divided by 3x minus y all over x minus y. All over xy. So I can't do anything else inside the parentheses. So let's go ahead and let's just divide these two. Let's stay, change, flip. Stay, change, flip. Our first fraction staying the same. 3x plus y times 3x minus y all over xy. Changing our operation from division to multiplication. We're going to flip that second fraction. So xy all over 3x minus y. We are dividing so we can multiply straight across. If you want to simplify here, go for it.
Get rid of the xy.
3x plus y times 3x minus y times x times y all over x times y times 3x minus y. My favorite part, what cancels? What cancels out? What's on the top and on the bottom? Y and x. And what else? 3x minus y. What's left over up top?
3x plus y.
3x plus y all over?
1.
1.
Boom goes the dynamite.
Boom goes a dynamite, which is just 3x plus y. There she is.
Yeah, you were about done with this.
There's 2 more on that page? There's 2 more on that page?
Yeah.
Yeah.
All right, so 2 more questions left.
The last one looks like a flux fraction on steroids.
Oh boy.
Like, what is going on?
Aren't you excited to try it?
It's like a flux fraction on steroids. Why would I be happy to try it?
Because it looks hard, but it's a challenge that we are going to overcome together.
It looks like an EPL Live if it could.
It probably will.
Math is a lie. We should abandon it.
Math is not a lot.
Matt,
All right, ready for the next page.
why are we going to use complex
Have you seen the next
fractions?
page? That's a disaster. She's not happy.
It's Colgan.
Like, let's do it.
Let's do it.
Yeah.
Yeah, I mean, you're so scared. I'm here to help you. Let's do it.
Sure.
Same exact thing we've been doing. Nothing new. I don't know why it's so scary now. Nothing's new.
We went from 5 steps to 57, and it's no big deal.
It's no big deal. No big deal. All right, so simplifying the complex fraction. Let's focus. Ready? We have to do it, so let's focus. Ready? Here. Simplifying the complex fraction. 3 over 6 minus x plus 4 over x minus 6 all over 3 over x plus 3 over x minus 6. All right, so this middle fraction bar, same exact thing we've been doing this whole time. We're going to write it as division. So we have 3 over 6 minus x plus 4 over x minus 6 divided by 3 over x plus 3 over x minus 6. So, looking at this, we are doing whatever's inside the parentheses first. So we are only dealing with these two fractions, adding 3 over 6 minus x plus 4 over x minus 6. Are these like terms?
No.
No, they need to make them like terms. So for this first one, let's flip this around so we can have apples to apples. So we have negative x plus 6. The other one is x minus 6. What should we do to get common denominators? Factor out that negative 1. So we have negative 1 times x minus 6 in our first denominator and x minus 6 in the second denominator. So looking at this, what is our LCD?
Negative 1.
Negative 1 has to be there. What else?
X minus 6.
X minus 6 has to be there. So our LCD is negative 1 times x minus 6. Our first fraction is already negative 1 x minus 6 in the denominator, so it's good to go. Second fraction has x minus 6, but it's missing negative 1. So we're going to multiply the top and the bottom by that negative 1. So that'll leave us with 3 over negative 1 times x minus 6 plus 4 times negative 1 is negative 4 all over negative 1 times x minus 6. Now they are like terms. I can rewrite them as one big fraction. So 3 plus negative 4, which is just 3 minus 4, all over negative 1 times x minus 6. What is 3 minus 4?
Negative 1.
Negative 1. So negative 1 over negative 1 times x minus 6. Go ahead. What do you notice? Yep, factor out those negative 1s. What's left over up top?
1.
Positive 1 over
X minus 6.
x minus 6. I don't know what I'm going to do about room. We'll get there. So just dealing with that first fraction. Are you still breathing?
Yeah.
Are you? Yeah, barely.
No, we can do it again.
Yeah, so let's do it again.
What's here the next one?
All right, so divided by 3 over x plus 3 over x minus 6. So now just looking at the second one, our denominators are x and x minus 6. LCD. By the way, they're not like terms, so what's our LCD? X times x minus 6. Our first fraction has an x in it. It's missing x minus 6. So we're going to multiply the top and the bottom by x minus 6. Our second fraction has x minus 6, but it's missing an x. So we're going to multiply the top and the bottom by x. So we have 3 times x minus 6 all over x times x minus 6 plus 3x all over x times x minus 6. Now these are like terms. They are both x over x times, let me start over. They are both over x times x minus 6. So I can rewrite it as one big fraction all over x times x minus 6. Can I skip a step and can I go ahead and distribute my 3?
Why did you do that?
Because these two things are being added together. So, okay, I'll write it out.
But you just said the last one we need to simplify.
Yeah, you're right. I did say that. But they were already factored, right? They're already factors. Factors mean what? Two things that are being multiplied together. These are not factors because these are two things that are being added together. So these are not in factored form yet. So we have to get them in factored form. So that means I have to distribute, combine like terms, and then factor. Do you see the difference? Do you see the difference?
Yes, I was
Three X
working
minus
as you're
18.
talking, and I went to go distribute it, and then I was just like, you just said don't distribute it, but then I erased it, and now we're
Yep.
distributing it anyway.
You do distribute because of that plus sign. That plus sign is what messes us up and makes us have more work. So, divided by 3x minus 18 plus 3x all over x times x minus 6. Combining like terms, 3x plus 3x, 6x minus 18 all over x times x minus 6.
Now we factor out
Now you factor out what? GCF at the top, 6x minus 18.
6.
6.
Yeah.
Yeah. So now we have 1 over x minus 6 divided by 6 times x minus 3 all over x times x minus 6. So they're in factored form. They're all being multiplied together. So now we simplified as much as we could. Now bringing it together, we're going to divide. So we're going to stay change flip. The hard part's done. So 1 over x minus 6 times x minus 6 all over 6 times x minus 3. Multiplying straight across as one big fraction. I have x times x minus 6. I don't need to write the extra 1. All over x minus 6 times x minus 3. Therefore, x minus 6 cancels out. Our final answer, we're left over with x up top and 6 times x minus 3 on the bottom. So it's going back to Module 7, Homework 3. We're doing 2 addition problems, putting it together, doing a division problem, and then simplifying as we go. So all together in one. Nothing's new here. Just putting it all together. How could I help you understand this better? What questions, comments, or concerns do you have for me, please? What? Are you laughing because I always say that?
No. I'm just laughing because I don't like this.
Oh, because you're looking at the next one?
I don't like where this is going.
Let me make you feel a little better. Never mind.
Never mind.
I don't have anything to make you feel better.
We're just looking at this next.
Okay, so to make you feel better, Module 9 is going back to Test 1. It's literally just review, so you have a little bit of a brain break in a minute. But let's get through this last one first. All right, so last one for this section. We can do it. Last one. 2 over x plus 4 plus 8 over x plus 5 all over 5x plus 21 all over x squared plus 9x plus 20. Looks scary, but let's just dive right into it. So this middle fraction bar, same thing as before. We're going to rewrite it as division. I'm going to move this down here. So we have 2 over x plus 4 plus 8 over x plus 5 divided by 5x plus 21 over x squared plus 9x plus 20. So same thing we did before. We just rewrote it as a division symbol. Now we're just going to look at the first set of parentheses. 2 over x plus 4 plus 8 over x plus 5. Are these like terms?
No.
No, we have to make them like terms, so we need to get an LCD. Going from left to right, x plus 4 has to be there. X plus 5 has to be there. So our LCD is x plus 4 times x plus 5. Our first fraction already has x plus 4, so it's missing x plus 5. So we're going to multiply that to the top and the bottom. Our second fraction has x plus 5. It's missing x plus 4. So we're going to multiply that to the top and the bottom. Nothing crazy yet. Nothing crazy. Yet.
Yet.
Just kidding.
Gotta emphasize that yet.
Yet. So we have, both have the same denominator of x plus 5 times x plus 4. So we can rewrite it as one big fraction all over x plus 5 times x plus 4. So our top is 2 times x plus 5 plus 8 times x plus 4. So because these two things are being added together, they are not factors yet. We have to get it in standard form so that we can factor it. Meaning I have to distribute combined like terms so that we can factor it. So let's distribute. So we have 2 times x plus 5, 2 times x plus 5 plus 8 times x plus 4, all over x plus 5 times x plus 4. Let's distribute our top, distributing this 2, distributing this 8. So we have 2x plus 10 plus 8x Oh, I forgot 32, sorry. Plus 32.
Here's all the controversy going on.
All over x plus 5 times x plus 4. So we can combine like terms. So we have 2x plus 8x will give us 10x. 10 plus 32 will give us plus 42. All over x plus 5 times x plus 4. Getting closer, we have it down to one fraction. So now looking at 10x plus 42, GCF. 2. Taking out that 2, we're left with 5x plus 21 all over x plus 5 times x plus 4. There's nothing else we can do with that fraction. It's done. We're going to leave it till the end. Looking at our other fraction, we have divided by 5x plus 21 all over x squared plus 9x plus 20. Thankfully, it's one fraction. That's cool. So we have all of our like terms combined, so we can try to factor. Looking at 5x plus 21, GCF.
5x plus 5x plus.
Yeah, the top.
Oh, the top, nothing.
Yeah, nothing. No, you're good. Keep that in mind. The top, no GCF, nothing we can do. It's going to say 5x plus 21. Looking in the back of our mind, that looks good. There's another 5x plus 21, so that looks hopeful. Looking at x squared plus 9x plus 20, let's factor. What's our first step in factoring?
LCD.
Yeah, the other three letters. GCF,
GCF.
which is none, so no GCF. Our A value is 1, B is 9, C is 20. So we're looking for two numbers that will multiply together to give us 20 and add together to give us 9.
4 and 5.
4 and 5. So we can go ahead and go to x plus 4 times x plus 5.
I see it's happening here. Can we just skip all the way down to the end?
Yep.
Because that was pretty simplified right there.
Yeah, so it's really not as bad. You guys are freaking out. Not that bad.
That looked huge.
It looks scary, but you can do it.
This will be the only example that pretty much everything ever cancels out. The rest of them are going to be like, here's this massive answer you got to type into math.
No, they usually happen like this. It's not bad. So you kind of in the back of your head can know 5 and 4 might be an answer. All right, so yeah, nothing cancels out. Let's just go ahead and bring it all the way down to the bottom. So we simplified both parentheses, both sides by themselves until we can't simplify it anymore.
I knew it.
So 2 times x, 5x plus 21. Let me start over. 2 times 5x plus 21 all over x plus 5 times x plus 4 divided by 5x plus 21 all over x plus 4 times x plus 5. So now we are just dividing. So we can state change flip. And then our favorite part, cancelization. So our first fraction is going to stay the same. 2 times 5x plus 21 all over x plus 5 times x plus 4 times x plus 4 times x plus 5 all over 5x plus 21. So looking at this, we are going to multiply straight across. So we know this is going to become one big fraction. So what cancelizations?
Pretty much everything.
Pretty much everything. So 5x plus 21s go away. X plus 4s go away.
Yes, it does.
X plus 5s go away.
Oh, yes, it does.
Oh, yes, it does. So after this whole crazy mess that y'all were crying about, what's left over up top?
A 2.
2. What's left over on the bottom?
Oh, 1.
1. So all this crazy, that's like makes it even worse.
Yeah, all this cover and 2.
All this crazy mess and our answer is just 2. All of this crazy mess and our answer is just 2. So what questions, comments, or concerns do you have for me, please? This is Module 7, Homework 4 Notes.
That's like a fraction on steroids.
But now look, you accomplished your goal.